Hello and welcome to video part 2 of the review for the stats final. This is going to be about picking the right test statistic. So again, you should have hopefully attempted to do this on your own first before you look at these videos. I wanted to first start off by pointing out Appendix I. I've done this before, but this is a decision tree. It will help you decide which statistic to use. So I'll just quickly walk through this and then we'll go through the actual examples on the sample final. What I would encourage you to do first as you read a scenario is to identify if you are comparing sample means at all. When you read the scenario, are you identifying that you're comparing a group, an identifiable group? You're comparing their score on something to something else, and you're not a variable, but a group. You have a sample, a group of people who you're going to get a mean on some value, and you're going to compare that mean to something else. If you're going to be doing that, then you're going to be getting one of these statistics. Either the Z for sample mean, single sample t, independent t, related t, one-way ANOVA, or two-way ANOVA. And now you got to answer, how many different sample means do you have? If it's only one, then it's got to be either the Z for a sample mean or a single sample t. And the way you decide between those two is whether or not you know the population standard deviation. Not just any standard deviation, but the population standard deviation. If you do, it's a Z for a sample mean. If you don't, it's a single sample t. Again, if there's only one sample, there's only one group, and you're comparing that group's mean to some other value like chance performance or some known population mean, then you want to use one of these two. Now, on the other hand, if you have two groups or two sample means, you have two choices. It's either an independent t or related t. And the way you need to decide between those is whether or not the two samples, the two groups, the two means that you're going to have, are they coming from groups that have different people in them? If they do have different people, like men and women, or sixth graders and fifth graders, different people, that's an independent t. However, a related t is one where the two sample means are related somehow, and they can be related in some way in two different ways. One, you can have the same people in both groups. Like I measure everybody in a sample on task 1, and then I measure the exact same people again on task 2, and then compare the means on task 1 to task 2. That would be a related samples t because you have the same people in both groups. Another way that you can have a related t is if you have different people in the two groups, but those two different people are in some way matched. So if you match them on cholesterol level, you have two people with 150 cholesterol and you put one in one group and one in the other. Or if you have a married couple and you want to compare, you put one spouse in one group and the other spouse in the other group. Obviously they're not the same people, but they're related, right? Because it's not just any married person, they're married to each other, and you have one in each sample. So those samples are related in some way. So that in that situation, you would use a related t. And then finally, if you have 3 or more groups, it's either a one-way ANOVA or a two-way ANOVA. If you know that it's 3 groups, it has to be a one-way ANOVA. That's pretty straightforward. Now, the two-way ANOVA is a little more complicated in that you have to identify the independent variables. Most of the time, you're going to have a situation where you have one variable that has 2 or 3 groups in it, and another variable that has 2 or 3 groups in it, most of the time 2. And when you cross them, you have 4 different groups. And we'll see some examples of that in our activity, so I won't go into that right now. So again, these are all of the tests that you know that compare means to each other or some other value. The other tests that you know are the correlation tests, and you have either the Pearson correlation or the Spearmint correlation. And so what you really need to do here is identify the two variables and then identify how they're being measured. If the two variables are both interval and ratio in scale, they're either both interval or both ratio, or one's interval and one's ratio, either way, then that's going to be a Pearson. However, if even one of those two variables is measured on an ordinal scale rather than an interval ratio scale, an ordinal scale, again, is you know that a given person has more of something than maybe another person, but you don't know exactly how much more. That's an ordinal scale, and so that would mean you'd have to use a Spearmint correlation. And on the pick the right test statistic things, I won't be asking you to look at scatter plots, but of course, in a bigger scale of things, you might also use a Spearmint if you have a scatter plot that suggests that's necessary. Okay, so now we're ready to dive into the actual questions. Question 1 is correlation, because you've got two variables, and one variable is height, which is an interval ratio variable, and the other one is popularity rating, which ranges from 0% to 100%, which is also an interval ratio variable. So you've got two interval ratio variables, and you want to see if they're associated with each other, so that's a Pearson's correlation. If someone's height goes up, does their popularity go up? If someone's height goes down, does their popularity go down? You're not comparing groups, you're comparing people's scores, or people's scores on variable 1 and variable 2, and trying to see if they are related in some way. If there's a trend that if one goes up, does the other go up? If one goes up, does the other go down? So that's a correlation situation, and in this case, a specifically Pearson correlation situation. The next one is Z for a sample mean, and that's because you have one sample mean, and the mean is the mean number of words recalled, and you just have one sample, one group, and you're comparing that one group to a population mean. And you do know the population standard deviation, so that makes it a Z for a sample mean. Okay, and then 3 is also a Z for a sample mean. In this situation, you again have one sample mean. It's mean religiosity. You're measuring one group of people, you're measuring their mean religiosity, and then you're comparing their mean religiosity to, again, a population mean, and you do know the population standard deviation, so it is a Z for a sample mean. Again, it's not just any standard deviation that you need to know, it's the population standard deviation that you need to know in order to do a Z for sample mean. For 4, it's an independent T, and the reason why is you have two groups, and you have different people in those two groups. You have two different groups of people, and you're comparing them on GPA, and so that's an independent T. Number 5 is a one sample T. Again, you have one sample or one group, and you're comparing the mean of that one group, it's a test score, their mean test score, to chance performance, which is 25%. Now, that's not a population mean, but it is a set value of interest. And of course, you don't know the population standard deviation because there really isn't the population you're comparing it to. You're comparing it to this chance performance of 25%. So you don't know the population standard deviation, so that makes number 5 a single sample T. Number 6 is our first example of a Spearmint correlation. You have two variables, and they were the years of education, but you have to keep in mind how years of education was measured. It was measured on an ordinal scale. It was measured as through high school, or through junior high, through high school, some college, and completed college, and so that's an ordinal scale. You don't know exactly how many semesters or how many years people have, so it's an ordinal scale. The other one is also measured on an ordinal scale because it's income, and you're measuring that as below the poverty line, and then other different categories all the way up to more than $1 million a year. So both of those are ordinal. You don't know exactly how much more one person has than the other if they're in the same or different categories. So again, this is the relationship between two ordinal variables, Spearmint is the correct choice here. Number 7 is a single sample t again. You have one group, one sample mean, and you're comparing that to a national acceptable value of 7. And you do not know a population standard deviation, again, because it's not really a population mean you're comparing it to. It's just this professional standard of a 7. So you don't know the population standard deviation, so number 7 is a single sample t. Again, just one group, and you're comparing it to a set value. The next one is our first example of a related samples t-test, number 8. You have really one group, but you have 2 sample means coming from that same group. This group rates a sandwich shop on how good their sandwiches are on a scale of 1 to 10. Then they write some persuasive essay, and the idea here is that the persuasive essay is going to make them think that that sandwich was actually better than it was later. And then a week later, they try it again, and they give another rating. So you're rating the same people twice, or you're having the same people twice give a rating at time 1 and give a rating at time 2. So that's a related samples t-test because you're measuring the same people twice. The next one is another example of an independent t-test, number 9. You have 2 groups with different people in the 2 groups. And these 2 groups are using different study methods, and they're going to be compared on their mean number of words recalled. And so this is 2 groups, different people in 2 groups, independent t. Number 10 is a two-way ANOVA. So again, these are the hard. This is probably one of the harder ones. You have a variable that is people who get to take sample quizzes and people who don't. So that's one independent variable that has 2 levels. People either get to take a sample quiz or they do not. And then the other variable is when they take the test. They either take the test after some delay period or really right away. And so you've got 2 independent variables with 2 levels each. So by crossing them, again, you have some people who are getting a sample quiz and taking the test immediately. Some people who are not getting the sample quiz and taking it immediately. Some people who are not getting the sample quiz, all 4 combinations, right? So this, and you're crossing them. So this is an example of a two-way ANOVA. Number 11 is an example of a Spearmint correlation again. The first variable you're not comparing sample means at all. You have a measurement of everyone on their income that is measured on an ordinal scale again, just like we did in a previous question, putting them into categories of below poverty line all the way up to different categories that are higher to $1 million a year. And the second variable is number of times they're burglarized, which is a ratio variable. So now we have one ordinal variable and one ratio variable. And in that situation, you have to use a Spearmint correlation. And now number 12 is a Pearson correlation. And the question they're asking is depression experienced by the mother and father of a kid that was just born similar? So this is really measuring something like something called postpartum depression. So if the mother, we measure both the mother and the father on their depression level after they've had a kid. And we want to see if they're associated. If the mother tends to be depressed, does the father also tend to be depressed? And vice versa. So again, you're measuring this depression variable on the mother, and you're also measuring it on the father, and you're trying to see if they're related, if they're associated. This would be a Pearson's correlation here because both of those variables are measured on an interval ratio scale because the depression score is measured from 0 to 88, higher score meaning more depression. So 2 interval ratio variables, you want to see if they're related. or associated with each other. Next question is question 13. Question 13 is a one-way ANOVA, and it's comparing three groups. You have a group of mothers, or you have a sample of mothers, and you have three different groupings of them. You have 20 that are in a low SES group, 20 that are in a middle SES group, and 20 that are in a high SES group. So that's three different groups of mothers, and you're going to be comparing them on some dependent variable. And so this is a one-way ANOVA. 14 is also a one-way ANOVA. It's comparing three groups of women this time on a depression score. And you have 75 women, 25 of them work full-time outside the home, 25 work part-time outside the home, and 25 don't work outside the home. So again, you're comparing three groups of women, in this case, on depression score. So again, this is a one-way ANOVA. And our last question is a two-way ANOVA. In this case, you have two independent variables. One of them is gender with 2 levels. And then the other independent variable is your working situation, just like we said above. So we have a bunch of fathers and we have a bunch of mothers. So that's one independent variable. And then the other independent variable we have is people who work outside the home full-time, people who work outside the home part-time, and people who work outside the home never, right? So this would be a 2 by 3 factorial ANOVA, two-way ANOVA, because one of the variables has 3 levels, one of the variables has 2 levels, and so you would combine those. So now you have men who work outside the home full-time, men who work outside the home part-time, men who never work outside the home. And then you have women who work outside the home full-time, women who work outside part-time, women who never do. And so that creates 6 different groups in this case because you're crossing those 2 independent variables. So this is a two-way ANOVA. And that brings us to the end. Congratulations if you made it this far. If you have any questions, please do email me. And I will be doing my very best to respond to emails as quickly as I possibly can.